Hello everyone, I hope you guys are doing and staying safe. Welcome to SimpliCode's YouTube channel, and in today's session, we'll understand how to implement queues using a singly linked list. Now, a queue is a linear data structure that serves as a collection of elements which follows the first in, first out, or in short FIFO principle, which means the first element added to the queue will be the first element removed, with two main operations which are Enqueue and Deqeue, which are used for insertion and deletion from a queue. Now we have discussed these operations in our previous tutorial where we have covered an array implementation of queue data structure. So if you haven't checked that out, make sure you check that out on our channel. We will leave the link in the description box below as well. So in this session, the linked list implementation of queue will be discussed, its operation using C++. So without any further ado, let's get started. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So let us now directly jump into Visual Studio Code for execution. So as you can see, Visual Studio Code has started. Now, before we get into the execution or the implementation part, let's just understand why use linked list when we already have arrays instead of arrays, right? Now, the implementation of queues using data structure like array comes up with some limitations in terms of memory wastage. And while designing solutions and algorithms, we should always protect these crucial resources by analyzing all the developmental implications. So the technique of queue implementation using an array has some limitations or drawbacks, which is one of the main reasons why we are taking linked list. Now, one of them is basically fixed size of array, which is one of the main drawbacks, right? So, but what is fixed size? So, array we know is a static data structure. That means we have to predetermine the size of an array before the execution of any program. Additionally, the size cannot be updated at runtime. So, this fact about array violates the primary feature of a queue, that it can be extended at a runtime. Now, obviously, the second reason would be memory wastage, which is another factor or a drawback of using an array. Now, when the array gets exhausted, we cannot update its size at the runtime. This scenario leaves us with only one option, which is to create a new array and copy the contents of the previously used array into it. But this approach also brings more advantages to the table, which is the reason why we do not use arrays in such situations when there is a limitation of the array size. So with that, we are using linked list as a fundamental data structure to use or to implement queues. So let us understand how it is done. So let me just keep this as a comment to here. So firstly, let us include the header files, which is again #include iostream, and then using namespace std as usual. So firstly, we will define a structure for the linked list node. So I am taking struct node, wherein I'll pass a data type value, int data type, which will store the value in our queue, and then we will pass a next pointer which will point to the linked list in that queue. So I hope you understood. So nextly, we will define a class for the queue. So basically, firstly, we are defining a node class to represent each element in the queue. Each node contains an integer data and a pointer to the next node in the queue. So next, let us create a class queue, and inside that, I'll create a private member function, and I'll create a pointer to the front of the queue. So let's take node asterisk front as a pointer to the front of the queue, and similarly node asterisk a pointer to the rear of the queue. And then I'll create a public member function wherein I'll create a constructor to initialize the front and rear pointers. So call the constructor, which is queue, and inside the square brackets initialize the front to the null pointer, and similarly rear is equals to null pointer. So I hope you have understood this. We have defined a queue class to hold the nodes and perform queue operations. The class has private member variables which are front and rear, which points to the front of the queue and rear, again, which points to the rear of the queue as well. So we are initializing both these pointer to null in the constructor. Now let us write a function to check if the queue is empty or not. So for that, I am taking a Boolean function. So I am taking a Boolean function which is empty is the function which is used to check if the queue is empty or not. So if it is empty, it will just return the value, that is return friend is equals to null pointer. All right. So we are done with the creating a function to check if the queue is empty or not. Next, let us create a function to enqueue or to insert an element into the queue. So for that, let us take a void function. Void, let's take it as enqueue, the function name, and inside that I'll pass a parameter of int data type and store a value which is data. So firstly, let us create a new node. So firstly, node asterisk new node is equals to new node. Next, we will store the data inside that. So new node will point to the data and will store the value inside that pointer. So next, we will create a next pointer which will point to the null pointer, right? So new node of next becomes the null pointer. So again, we will check if it is empty or not. If the queue is empty, we will assign the new node to the front and the rear, else the rear of next will become the new node, right? So if is empty, in such case, front is equals to rear is equals to new node. Else, the rear of next becomes the new node. All right. So this is basically a simple implementation of a linked list. I hope you've seen this in our previous videos also, where we have done some operations like insertion and deletion, wherein we are trying to add elements to our linked list. So which is similar to that again. So rear of text becomes a new node, and we will assign the rear is equals to new node. So that's it. Once this is done, we will make sure that the element is inserted. So I'm just creating cout data, wherein we will say that enqueued or inserted, it is the one and the same, so you can keep it as in any way. So enqueued into the queue. So I hope you've understood this. This is basically, we have created a function to insert an element, wherein we are using the enqueue function. So quickly, just to understand what you've done here, the enqueue function adds an element to the rear of the queue. So it first creates a new node with given data and sets its pointer to the null pointer. And if the queue is currently empty, it sets both front and rear pointers to the new node, which we have done here. Otherwise, it sets the next pointer of the current rear node to the new node and then sets rear to the new node. So similarly, we will create a function to remove the elements from the queue as well. So for that, we will create a dequeue function. So let us create that. Void dequeue is the function name. And firstly, we will check if the queue is empty or not. If it is empty, we will say that queue is empty, which will return the value again to us. So if is empty, which is basically the function which will check if the elements are there or not in our queue, we will return cout queue is empty. All right, queue is empty, cannot perform dequeue is the message we will return. All right, cannot perform dequeue. So I hope you have understood this. And basically, we will end the line as well. If else, if not, we will create another else statement, that is, we will remove the element. So where the element will be removed? Firstly, we will create a temporary variable which will point to the front of the linked list. So I'm taking node temp is equals to front. Now this front will point to the front of the next node. So front is equals to front of next, and then we will retrieve the value saying cout temp of data. That means we have successfully dequeued the element from the queue. So we will just say dequeued from the queue. Dequeued from the queue. Close the brackets and let's just end the line. Alright, so I hope you understood this. And just to reiterate what you have done here, the dequeue function basically is a function that removes and returns the front element of the queue. So if the queue is currently empty, it will print an error message and it will return this queue is empty, cannot perform dequeue. Otherwise, it sets a temporary node pointer to front and retrieves the data from that node, and it will set its front to its next node, and it will delete the temporary pointer. Okay, I haven't included that delete, so let's just add that. So finally we will remove the delete the temp value also. So delete temp. So make sure you add this, otherwise it will throw an error. So I hope you understood this. So once it deletes the temporary pointer, and it will check if the front row is now null, that means the queue is empty. So it sets the red to null as well. So let us now create a function to display all these values that we have inserted and deleted in order to display them. So I am taking a void display function, void display. So firstly, again, we will check if the queue is empty or not. So I'm using if statement to check, which is empty function I'm passing. Wherein we will see cout. If it is empty, we will return queue is empty. Alright, and close the brackets and end the line. Else, we have to retrieve the values. So since we have created a temporary value which will point to the front node, right? So else node asterisk temp is equals to front. Now the operations will be performed until the temp is not equals to the null pointer, right? So for that we will take a while loop while temp is not equals to null pointer. In such case, we will print the data. So cout temp of data will be printed each and every time. Alright. So and we will store this value. So temp is equals to temp of next. So finally we will end the line again, cout, end the line. So that's it, guys. I think we are just now left with the main function. So let us create one main function also. So int main, pass the instance. We have to pass an instance of the class by calling the class, which is queue. So let's just take the instance or the object of the class as queue, which can be your own choice. You can take it as per your wish. So firstly, let us try to insert some element. So queue dot, in order to insert the element, we will use the enqueue function. So queue dot enqueue. So the first element I am going to insert is 10. Similarly, we will insert some more elements. Queue dot enqueue 20. Similarly, let us insert one more element. Queue dot enqueue 30. I think 3 elements are enough to understand how it works. So again, once we have inserted, we need to retrieve the values. So for that, we have created a display function. So I'm using queue.display in order to retrieve the values. So let's just execute this and we'll see the output. So let us execute this and we'll see the output. So as you can see, it says 10 is enqueued into the queue, 20 is enqueued into the queue, 30 enqueued into the queue. So the elements in the queue are 10, 20 and 30. Alright. So let us now perform a dequeue operation as well, and let's see if the elements are being removed from the queue or not. So for that, I am taking queue.dequeue, which is the function to remove the element. So I'll just perform twice and we will see what happens. So I'm passing the dequeue statement 2 times here. So as you can see, that means the first 2 elements has to be removed. That is 10 and 20 should be removed from our queue, and only 30 should be displayed. So let us now see the output. A small error in the queue spelling. So now as you can see, 10, 20, okay, we have to display also, right? So let me just, so click on execute now. So 10, 20, 30 were the elements that were there in the queue first. Next we have dequeued 2 elements, which are 10 is dequeued from the queue and 20 is also dequeued from the queue. And now we are left with only 30, which is the element in our queue. Now let us try to add some elements and see whether or not they are added into our queue or not. So just use queue.enqueue and pass a value again. So let's take 50 and let's take 60. Queue.enqueue 60. Alright, so again we will display the values. So I'm using queue.display function. So let us now see the output. So 30 was the element that was there in our queue. Next we have inserted 50 and 60. Now since queue follows the first in first out, so firstly 30 will be pushed into the front. Next we'll add 50 next, and finally 60 will be added into the list. So in this way we can perform the implementation of queues using a linked list. Now, the main advantage of using linked list over arrays is that it's possible to implement a queue that can grow or shrink as much as needed. Now, since each node in a linked list will be dynamically allocated, overflow is not possible unless the memory is exhausted. But whereas using a static array will restrict the array's maximum capacity, which can lead to the queue overflow sometimes. So I hope you understood how to implement the queue operations using a linked list. Well, that brings us to the end of today's session, guys. I hope you've understood the operations like the Enqueue and Deqeue that we have covered in this tutorial. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics or concepts covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. If you want any resources like code, also make sure to leave in the description. We will try to add it as well. Stay tuned to the channel for more such amazing content, and if you want to learn more about data structures, we have a dedicated playlist on it where we have covered all the fundamentals of data structures, its various types like arrays, linked lists, tags and queues. So make sure you check that out. Until next time, thank you and keep coding.